we'll see the null point case, how to calculate the null point. See, I am taking a charge Q1 here, Q2 here, two are positive charges. So in between them, if I place a third charge, say Q3, at a distance x from Q1, the separation between them Q1 and Q2 say R. Then what is the x? So the net force acting on Q3 is 0. That is Q3 will be in equilibrium, only Q3. See here in the null point calculations, it is not compulsory that it is a stable equilibrium. It may be unstable equilibrium also. I will give clear-cut clarity between calculating null point and commenting whether it is stable equilibrium or unstable equilibrium. Okay, first we'll calculate this one. Very simple. Let us draw the free body diagram here. Q3 also say positive. Okay, then the Q1 will repel it. So I write it as F1. F1 is force on Q3 due to Q1 charge. See, this notation is our wish when you solve the problem. Or if you want to write F31, you can write. If you want to follow fixed notation, write F31. What is F31, Anna? The force on Q3 due to charge 1. Because both are same positive, same polarity charges, the repulsion takes place. The direction of repulsion is what? In the direction from 1 to 3. The line joining 1 to 3. That is only I drew. Next one. What is the force acting due to Q2 on Q3? It is again repulsive because both are positive charges. The direction is from 2 to 3. So this is F32, the force on 3 due to 2. Both are acting opposite to each other. So there is a possibility of getting a null point. That means what? That is when Q3 experiences a zero net force. I'm telling zero net force. It doesn't mean the no force is acting. Two forces are acting, but the resultant of two forces is zero. So Q3 will be at rest. That is when Q3 experiences a zero net force. That is F net equal to 0. Then a null point is said to be formed. This is Q3. F31. Chapandi, what is the equation for F31? K Q1 Q3 by distance square. What is the distance, Nana? X. Between Q1 and Q3, how much distance is there? X distance is there. Q1 Q3 by X square. What is this is F32. What is F32? What is the value? F32 equal to how much? Total distance is R. Total distance, separation between Q1 and Q2 is R. Between Q1 and Q3 is X. So what is the remaining? R minus X. So R minus X whole square. See here, because the F net is 0, since F net is 0, that means what? The magnitude of forces acting on Q3 will be same. So F131 equal to F232. Or if you want to write like this, use magnitude form. Mod of F31 bar is equal to F32 bar. Let us substitute here. F31 is what? K into Q1 Q3 by X square. This is equal to K into Q2 Q3 by R minus X whole square. So you can cancel K, you can cancel Q3. So this is R minus X by X whole square. Are you getting this? R minus X whole square, I wrote this side and making total square, that's all, is equal to Q2 by Q1. R by X is equal to 1 plus or plus 1. Therefore X by R, X needed kada, కాబట్టి X by R రాద్దాం, 1 by root over Q2 by Q1, root only for Q2 by Q1, remember. Therefore X is equal to R divided by root Q2 by Q1 plus 1. This is the important thing. The null point distance does not depend on the magnitude of charge that you have taken. Okay, that is very interesting thing. Clear? Right. So let us take Q1, Q2. Here we'll take minus Q3 between them. So Q1 is attracting towards it, Q2 is attracting towards it. So there is a possibility, of course, a null point is formed between them. Jagrata vinnandi. I am taking plus Q1, here minus Q2. So here if I place any charge, say take positive charge, plus Q1 repulses, minus Q2 attracts it. So on third charge Q3, what is happening? The force acting will be in the same direction. So here there is no possibility of forming a null point between two unlike charges. We'll make a point here. Between two unlike charges. So then where it will be formed, that also will see. Plus Q1 minus Q2 తీసుకుంటున్నాం. So here very important point we drew from the discussion. ఏంటి? The no null point is formed between the Q1 and Q2, Q1 and minus Q2, unlike charges. So for example, I take Q3 charge here at a distance x. Say the separation between Q1 and minus Q2 is r. Let us see at this point null point is formed or not. Okay. So Q1 is positive, Q3 is positive. This is force of repulsion F31. And Q2 is negative, Q3 is positive, so Q2 attracts it. Kabatti this is the direction of force. This is F32. So two forces are acting in opposite direction. So there is a possibility. So the null point is formed at distance x. See here, this is Q1 and minus Q2. I take a third charge Q3 here at a distance x. Let us draw the force diagram, vector diagram. This is free body diagram. Minus Q2 attracts Q3 towards it, Q1 repels it. So force acting in opposite direction. Okay. So in this case, the null point is formed. In case of unlike charges, a null point is formed any other side of the system of charges, two charges. Okay, that point you can remember. On a horizontal surface, it is placed and a spring is connected between them. How much charge is given to the system? Q charge is given to the system. Total blocks, because they are identical. This gets Q by 2 charge. Okay. And this gets Q by 2 charge. Like charge, this becomes positively charged, this becomes positively charged. And what is given? Total charge Q is slowly placed on the system, causing the spring to stretch to an equilibrium length of L2. ఎందుకు stretch అవుతుంది? When you give charge to the system, both are positively charged, they repel each other. Those two blocks repel each other. And also they are asking to consider those blocks are point charges. And comfortably we can apply Coulomb's inverse square law. Okay. So what is happening? Because positive charge is induced, positive charge is given to the block, they repel each other. Due to repulsion, spring will stretch. Stretching in spring takes place. When spring is stretched, a restoring force is developed in the spring. That restoring force tries to unstretch the spring. It tries to unstretch. When blocks are separated, when charge is given, what happens? This and this blocks move opposite to each other. Why? Say this is block 1, this is block 2. Then on block 2, F21 force acts along positive x direction. On block 1, F12 force acts along the negative x direction. So both are mutually opposite to each other. So stretching of spring takes place. When string is stretched, the restoring force will be developed in the string. In between I will write one more spring diagram. So initial length is L1 before giving charge. After giving charge, stretching takes place. Say this is after giving charge, plus. Now it becomes, say, some L dash. At this situation, what happens, Nana? A restoring force is developed. Restoring force in the spring. What is the formula? Fkx. I'm taking magnitude. I'm not taking minus. Minus kx. If you take vector constant, vector point, minus kx. Only magnitude I'm taking. And mentioning in opposite direction. So no need to take minus. So the restoring force that acts in the spring is F equal to Kx. How many forces are there? Now how many forces are acting? Any point you take at the spring point if you take, one is electrostatic force is acting, Coulombic force, and restoring force in the spring is developed. So mutually they are in opposite case, acting in opposite direction. After some time, a equilibrium state is obtained. That equilibrium length is given as L2. Therefore, what is the extension on x equal to how much? L2 minus L1. What is the final extension in the spring? L2 minus L1. This is basic thing, you know. So let us write equation. Restoring force. What is the Coulombic force? K into Q1 Q2. That is Q by 2 square. Q1 Q2 by distance square. What is the initial distance? L1 square. Length of the spring. What is the restoring force? K into X. Ikkada K nu small k. Otherwise, to avoid the confusion, here I will substitute 1 by 4 pi epsilon naught. ఏమవుతా ఉన్నారు, ఏమవుతుందన్న టెక్నికల్ గా మీకు ఇబ్బంది అవుతున్నట్టు. ఇక్కడ I will write 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught to avoid the confusion. So again, what is the restoring force? Fr equal to K into X. Magnitude only I am taking. K into X is how much? L2 minus L1. Simply equate them, substitute them. That's all. Equate Fr and Fc. Just substitute them. What they are asking in the question? What they are asking to find? The value of Q. Okay, that you can do. Continue it. You do it afterwards. So, for example, you take a positive charge. Similarly, the electric charge also possesses a field. Simply, I can write a simple one-word answer here. The region up to which the charge can influence. So that is we can call as its field. Okay. So electric field is the influenced region of that electric charge. We can call as electric field. Every charge or every electric field will have some capacity to attract a other charge, second charge, or repel a second charge. ఇక్కడ ఒక చిన్న టర్మినాలజీ చెప్తాను, మనం అదే యూజ్ చేస్తాం. నెక్స్ట్ సోర్స్ చార్జ్ అని ఒకటి తీసుకుంటాం. వి టేక్ సోర్స్ చార్జ్. వాట్ ఈస్ సోర్స్ చార్జ్ నాన్న? ద చార్జ్ అబౌట్ విచ్ we are studying. For example, a Q charge is taken of magnitude so and so, and what is the electric field, what is the force, etc., etc. These things we measure. Okay, that is called source charge. Source charge is the main charge which is under study. Let us take a test charge. It is a very smallest charge that will not influence field of source charge. Then it is called a test charge. అదే పాయింట్. ఈ టెస్ట్ చార్జ్ ఏంటంటే చార్జ్ which cannot influence charges or which cannot influence field of source charge. Magnitude of force experienced by a unit positive charge. Generally, in all cases, we use positive charge to define the things, to know the direction. ఇక్కడ ఈక్వేషన్ రాశాను అనుకోండి. We represent electric field strength with E bar. It is a vector. E bar is equal to F bar by Q naught Newton per Coulomb. This is formula. ఇక్కడ చూద్దాం. See, some charge has its electric field E bar. Okay, generally we represent electric field with uniform electric field with a parallel equally spaced lines. Okay, we represent E bar like this. So what is this direction? అంటే if you place, this is source charge, place Q. These are called electric lines of force. I will come to that point later, tomorrow or day after tomorrow. Plus Q is the source charge. Here you place a positive charge, small charge, test charge, positive charge. What happens when a repulsion takes place? This moves straight. So the path of that unit positive charge is the electric line of force. So here the representation of electric lines of force y like this is, that is the path of positive charge. అంటే ఏంటి? If you place a positive charge inside a electric field, the force acts on the charge in the field direction. జాగ్రత్తగా వినండి. On this, the force acts in the field direction. How much? F bar equal to E bar into Q naught. If I place a negative charge, in the electric field, ఇక్కడ చూడండి అన్న, ఇది సోర్స్ చార్జ్, ఇక్కడ పాజిటివ్ చార్జ్ పెట్టాను కాబట్టి ఇట్ ఈస్ మూవింగ్ ఇన్ దిస్ డైరెక్షన్. ఇఫ్ ఐ ప్లేస్ ఎ నెగిటివ్ చార్జ్, వాట్ ఈస్ ద డైరెక్షన్ ఆఫ్, ఇన్ విచ్ డైరెక్షన్ ఇట్ మూవ్స్? టువర్డ్స్ పాజిటివ్ చార్జ్, అంటే ఆపోజిట్ టు ద డైరెక్షన్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్. It experiences a force opposite to the direction of electric field, but same magnitude of force it experiences. You remember this point. Okay, so electric force on charges in an electric field is this. When you place a positive charge in an electric field, in the direction of electric field, I will make a point here, I will write it. Positive charge experiences force in the direction of electric field, E bar. Okay, negative charge, vice versa, opposite to this bar, direction of electric field. ఇక్కడ ఏం చేసాం? A simple pendulum is given. The simple pendulum mass is how much? ఎంత ఇచ్చారు అక్కడ? M. The mass of the simple pendulum is M. నేను అసలు ఇంకా చాలా కాన్సెప్ట్ చెప్పుకుందాం అనుకున్నాం. No problem. Simple pendulum mass is M and string length is given as L and suspended from point O as shown. Bob is given a charge Q. ఇక్కడ ఏం ఇచ్చారన్న? charge Q ఉందట, plus Q, positive charge. If see in the problem, if you find Q, it is plus Q, remember. If horizontal electric field is switched on, so the electric field applied is along x-axis, horizontal and along positive x-axis. Horizontal electric field is switched on, then what happens in electric field? We'll discuss that. Switched on in the region with strength E bar. Find the angle made by the string of pendulum when it comes to equilibrium. This is theta. So in equilibrium, it makes an angle theta. You have to find out. Chepandi is simple thing, very simple. In the electric field, E bar, when you apply E bar electric field, so the positive charge will displace in the field direction. Okay, అదే కదా కాన్సెప్ట్ మనం ఇప్పటిదాకా డిస్కస్ చేసింది. అంటే ఏంటి? This will get displaced in the field direction because weight is acting, it moves in circular path because it is fixed somewhere. Here torque is acted, we don't touch the torque concept. So what is the direction of electric field? What is the direction of force acting on it? Cheppanna, what is the force acting on the bob? Q into E bar. ఇంతకుముందు కాన్సెప్ట్. The electric field intensity ఏమని చెప్పుకున్నాం? electric field strength, force per unit charge, F by Q. So F equal to how much? Q into E bar. So how much force is acting on it? Q E bar. Simply magnitude will take QE. Let tension in the string is T. Let us resolve into components. ఇదన్నీ మీరు వెక్టార్ పాయింట్స్, వెక్టార్ కేసెస్ లో చేశారు కదా ఫస్ట్ ఇయర్ లో. దిస్ ఇస్ one component and this one is another component, perpendicular component. Weight of the bob acts vertically downward. So if it is theta, this angle will be theta. So this is how much? T cos theta, and this is T sin theta. In equilibrium, the forces acting on the bob will be same kada, they balance each other. So T, వినండి ఫస్ట్ వినండి, T sin theta is equal to how much nana? It should be equal to QE because ఇక్కడ ఫ్రీ బాడీ డయాగ్రామ్ ఇక్కడ గీస్తాను. QE acting like this. This is T cos theta and this is weight of the bob mg and this is T sin theta. So when the bob is in equilibrium, అంటే it is moved up to some height, made some angle theta with the hinge, with the vertical about a fixed point O, and it comes to rest because continuously we are applying electric field. It comes to rest. So that theta we should find out. So at that point, when it comes to rest, all the forces acting on that will be balanced each other. కాబట్టి T sin theta equal to how much? It should be equal to QE. T cos theta is equal to mg. They are asking about theta. కాబట్టి దీని రేషియో తీసుకుందాం. T sin theta by T cos theta. If you take the ratio between them, T get cancel. Sin theta by cos theta is tan theta is equal to Q into E by mg. And therefore theta is equal to tan inverse of QE by mg. Okay, consider a point charge. Let plus Q is a point charge. Okay, so this is Q plus Q. This is a point charge at a distance r. Somewhere here at a distance r, what is the electric field strength? Adi manaku question. At point B and at point B, what is the electric field strength? Then what should be the direction? Along positive x-axis. This is the direction of electric field strength. Formula for electric field strength anna at point P, the force per unit charge. If you place a unit charge over there, F by Q naught అనుకున్నాం కదా. What is formula for F? K Q into Q naught by distance square. అదే కదా F into by Q naught ఉంది కాబట్టి by 1 by Q naught. So this is equal to Q naught get cancelled. K into Q by R square. This is the electric field strength due to a point charge at a distance R. Remember, so electric field strength, extended charged body. Say some charged body is given like this. It has Q charge on it. If you want to find out at point P, what is the electric field strength due to this charged body? దీనికి ఏం చేస్తానన్న బేసిక్ ప్రొసీజర్ చెప్తున్నాను. What we do, simply we take a small part of the charged body, say it has dq charge on it. It is complete body, completely charged body. What we do is we take a point charge. Enduku? Why? Because we know formula due to point charge. The electric field strength due to point charge, we know that formula. Okay, if it is a uniform, only uniform body cases, extended uniform body. Due to small part of the body, how much electric field intensity is there at any point, and simply integrate the equation. Finally, you will get total electric field strength. That is the concept we follow. Okay. So from here, at a distance r, say the electric field intensity in the same direction. Let us take dq charge కాబట్టి de bar andam. Therefore de bar en రాయొచ్చు చెప్పండి. De bar is equal to ఇంతకుముందు ఫార్ములా రాసుకున్నాం కదా, k into dq by ఇది x andam, at a distance x andam, x square, the unit vector along this x cap. This is basic formula. Okay, therefore what is the total charge? Therefore total electric field strength due to given body, due to given charged body, what we do nana, simply we integrate integral de bar. This is equal to integral k dq by x square into x cap. Simple case. అంటే ఇప్పుడు మనం ఏం చేస్తామంటే we take different types of bodies, then we do టచ్ చేద్దాం. Okay, this is a positively charged rod. So you have to find out the electric field intensity somewhere here P. Say it has a charge Q and length of the rod say L. You take this region. It is nearer to the P. Take this region. It is little far compared to first region from P. And take end region. At what distance it is from P? The P is at a distance R from first region, first end of the rod. and P is at a distance R plus L. R plus L distance from the end region. Kabatti, simply you cannot take E equal to K into Q by R square. దానికి ఒక ప్రొసీజర్ ఉంది, అది ఇప్పుడు డిస్కస్ చేద్దాం. డిస్కస్ చేసి డైరెక్ట్ ఫార్ములా రాసేస్తాం అంతే, ఇంకేంటి డెరివేషన్లు చేయండి. ఓకే, అందుకని జాగ్రత్తగా వినండి. ఇక్కడ చూడండి అన్న, వాట్ వీ డూ ఇస్ వీ take a small portion which has a charge dq. Total charge is capital Q. A small portion will have dq at a distance x. The point P is at a distance x from the dq. So small region dq is a point charge now. Okay, dq is a point charge. What is the due to dq, what is the electric field intensity nana here? It is dE bar. Where is the point? The point is on the axial line of the rod, and the axis of the rod. The line passing through the center of the rod along the length is called its axis. On the axial line at a distance r at point P, what is the electric field intensity we are calculating? For that, what is the first step we took? Consider a small portion of small region or small portion of rod. That is the step 1. What is the step 2? What we do? Calculate electric field strength due to that small charge dq. What is the third step? To get total value, to get E bar, simply integrate that dE bar. That's all. dE equal to how much? K into what is the charge? dq. At what distance it is? X distance. So x square. Clear? To get total value, what you have to do? You should integrate this equation. So E is equal to integral dE, integral K into dq by x square. What are the limits, integral limits? From where to where you have to consider? From the rod first point, first this position to this position. Point P is there. Total rod you have to consider. The point P is at a distance r from the first end of the rod. What is the length of the second end? R plus L. The length of the rod is L. So R plus L. So what are the limits from R, that is first end, to last end, that is R plus L. Okay, remember. Now next, one more important point. Generally, a rod is given if the along the throughout the rod, if some charge is distributed, we write one important parameter called linear charge density. మీరు ఫస్ట్ ఇయర్ లో డెన్సిటీ, లీనియర్ డెన్సిటీ, సర్ఫేస్ డెన్సిటీ, వాల్యూమ్ డెన్సిటీ ఆర్ సింప్లీ డెన్సిటీ అని చదివింటారు. ఏంటది? ఇన్ టర్మ్స్ ఆఫ్ మాస్. సో లీనియర్ చార్జ్ డెన్సిటీ, వాట్ ఈస్ ద లీనియర్ డెన్సిటీ అన్న? మాస్ పర్ యూనిట్ లెంత్, మూమెంట్ ఆఫ్ ఇనర్షియా, సెంటర్ ఆఫ్ మాస్ కేసెస్ లో, ఇన్ డిఫరెంట్ మన మెకానిక్స్ పోర్షన్ లో చదివింటారు. లీనియర్ డెన్సిటీ ఏంటి? లీనియర్ డెన్సిటీ మాస్ పర్ యూనిట్ లెంత్. ఓకే, వాట్ ఈస్ ద సర్ఫేస్ డెన్సిటీ? మాస్ పర్ యూనిట్ ఏరియా. వాట్ ఈస్ వాల్యూమ్ డెన్సిటీ ఆర్ సింప్లీ డెన్సిటీ? మాస్ పర్ యూనిట్ వాల్యూమ్. ఇక్కడ ఏం అడుగుతున్నాను? లీనియర్ చార్జ్ డెన్సిటీ అంటే చార్జ్ పర్ యూనిట్ లెంత్. ఇఫ్ ద రాడ్ హ్యాస్ L length and has Q charge, Q by L we can write, we can represent with lambda. This lambda is constant for any part of the body you take. Okay, here L length is taken. For example, you take small length dx. We took dx length, dq charge. What is the lambda? Lambda for total material. It is material property, constant. Ante lambda you can write as Q by L. Same lambda you can write as dq by dx. Ante dx part of the body you have taken. If it has dq charge, you can write dq by dx. That is also equal to lambda. Okay. So in this equation, in the integration part, dq n writes from this equation, dq equal to, you can write as Q by L into dx or lambda dx. From here, these two you take the cross multiplication. dq equal to dx into Q by L or dq equal to lambda into dx. You can write anything, no problem. Let us substitute in that equation, r to r plus L k into what is dq nana? Q by L dx by x square. ఓకే, చెప్పండి మీరు ఇంటిగ్రేషన్ పర్ఫెక్ట్ కదా. ఇక్కడ ఏమేం కాన్స్టెంట్స్, k is constant, q is constant, l is constant. We can write outside. What is the integration of 1 by x square? Very good, minus 1 by x. Minus 1 by x. What are the limits nana? R to r plus l. So if you substitute the upper limit minus lower limit, those things if you substitute, you will get kq by l into 1 by r 1 by r minus 1 by r plus l.